Well, good morning. It's my pleasure to be the first keynote speaker. I'm just going to jump right in, given this nice introduction, and share with you one of the most amazing things that happened in Bing's history. And it's this simple idea that somebody had to take the headline for ads, combine them with the first line, basically move the first line up to the first line of the ad here. And I want you to just look at this for a few seconds. This is an idea that somebody proposed, and it looks trivial. And when you think about it, it's one of hundreds of ideas that were proposed. And your answer is probably going to be similar to what many of us thought. Meh. So this idea, in hindsight, we looked at it, it was delayed in February, and in March of that year, and in April, and in May, and in June. And we had multiple features stack ranked way, way above this. And it was clear that this wasn't going to make it by the end of the year. And the engineer that looked at this said, God, this is so trivial to implement. Why don't I just get it off the backlog? And so it took him a few days. He implemented this, and his comment at Bing, he started a A/B experiment called flights, by the way, at Microsoft, one of those historical things that you think back and you go, wow, it's like people that invented the term didn't realize there was a whole literature dating back 100 years about controlled experiments. But he started this experiment or a flight, and an alert fired. The alert said, wait, something is wrong with our revenue because we are making too much money. And by the way, this alert is really useful. It has fired multiple times, and somebody would log revenue twice. And we would find a bug and fix it. But this time, there was no bug. This idea increased our revenue by 12%. At the time, we were about a $1 billion, Bing division. So it was worth 120 million annually. Today, it's worth 3-4 times that. But what's unique about this, it improved revenue without hurting what we call the guardrail metrics. It is very easy to make more money by hurting the user experience. What was unique about this experiment is that it didn't hurt them. And so considered today, I think one of the most valuable ideas ever in Bing's history. It generated, as I said, over $100 million in incremental revenue. But the thing that I want to, message to you is we never thought this was a good idea. Right? And this is one of the most humbling things about controlled experiment. We are wrong so many times. We don't rank things correctly. We think it's a great idea, and we're wrong. And I'll share with you some of the statistics. Adil shared a few. So I want to start with the hippo. This is one of the things that we did early on to try and help to change the culture. And I love this quote by Jim Barksdale. He said, if we have the data, let's look at the data. If all we have are opinion, let's go with mine. And by the way, this is just fine. I mean, the intuition of somebody high is probably going to be slightly better than yours. But the way to change this is really to inform the hippo with data. And by the way, for those of you who don't know the acronym that we invented way back in 2007, it stands for the highest paid person's opinion. And this was in a meeting that Avinash Kaushik and I had in Palo Alto down there. He said they were using hippo, and I said, my God, hippo is used for high potential at Microsoft. We can't do that. So we came up with this version, and that helped us change the culture. So we made thousands of these and handed them at Microsoft and conferences, but basically the message is try to inform the hippo with data. The best way to inform the hippo is with controlled experiments. By the way, this is a cool fact. Hippos kill more humans than any non-human mammal. It is, it's one of those things that's very skewed towards Africa when people try to step on them at dark and they get mad at you. By the way, if the mammal wasn't there, then the #1 killer is the mosquito. But yeah, don't let hippos kill good ideas, and listen to the customers, because what they really are the ones that matter. So I want to back up a little bit and just tell you why you should listen to me. Hopefully there's some information in this talk that you will like. But I've been running this analysis and experimentation team at Microsoft. This is our mission statement, to accelerate innovation through trustworthy analysis and experimentation. And I think one of the key words here that I want to make sure you think about is trustworthy. I'm going to share several lessons with you. It is the hardest thing to get right. It is very easy to produce results. It's very easy to show p-values with 5 digits after a decimal point, and the first one is wrong. We've been there. We have lots of scars to show that. And I've made comments on how many books get it wrong. I'll share with you some examples. But trustworthy is really one of those things that's hard to get right. We run one of the largest systems. In a typical month, we launch about 2,000 experiments. Think about a given day, somewhere between 50 to 100 experiments that start. We're used by many groups at Microsoft. We started our histories with Bing. This is where we scaled. I'll show you that. But now experimentation is running across all the large groups at Microsoft. And the transition hasn't been easy. I mean, I'm just going to share with you, the hippo, everything, the messaging, the cultural changes. These things take time. We're about 100 people, the main developers working on the platforms. About 60 people. We have 35 data scientists and we're what we call the center of excellence. There's the ones that help other groups basically empower them or teach them and educate them and try to accelerate the use of data and decision making at Microsoft. And then we have people from all over the place. I've been doing this for 13 years at Microsoft. Before that, I did this at Amazon. I was director of data mining and personalization. And this is where I had the epiphany of, my God, most of our ideas are bad. So when I came to Microsoft, I started building the system there. Scaling takes time. If you think about it, Bing today runs about 300 experiment treatments a week. And these are real experiments. Some people sort of run an MVT with 3 times 10 times 10 and claim 300. No, I mean, really, these are things where people think about what the results should be, and there's a hypothesis there. We typically expose our treatments to at least 1 million users in Bing. We can do that. There's this sort of law of conservation. If you're big, as Bing is, then you care about small percentages. If you lose 0.1% of revenue, you're going to lose $20, $30 million. So you want to be able to have enough statistical power to detect small deltas. If you're a small startup, you can run experiments with 1,000, 10,000 users because you're looking for the big deltas. You're looking for a big win. And it turns out that the math works out that if you want to look for big differences, you need a small number of users. The relationship is quadratic, so it's possible to run over a small set of users if you're looking for big effects. This is how we scaled at Bing. I just want to show you. It took years, right? We started off very few experiments, and it took us multiple years to get to the point where we are today. It sort of stabilized. It still grew. I mean, the graph continues, and like last year, we grew over 40% at Bing, but it's now not gated by the platform anymore. Every feature ships as an experiment. It's more gated by the ability of the developers to write code, right? In the beginning, in the early days, it was us. We couldn't scale the platform fast enough. We couldn't put people in multiple experiments. These are the things that you have to build over time. I want to talk about the life cycle. A lot of the talks that you see, people focus on, we can do this t-test, and I'll share with you some of the lessons that relate to, getting the math right. But experimentation is more than just that. It's about the full life cycle of evaluating an idea. So I'll take you through, what happens in practice. An experimenter will go to our system. There's a website. They'll set up the experiment. There's some design templates they can choose from. Do you want to run this design or this design or this design? It's not a lot of templates. We try to make it simple. There's a recommended design for most experiments. And then they hit the start button. That doesn't take anything to the live website. What it does is it first runs a set of gates. These are basically QA tests that every team that runs experiments can set up. And that just does basic stuff. And the reason we started these gates is that it's new code. New code has bugs. And we used to do stupid things sometimes, or there's a bug that we discover. So you have to pass the gates. You have to make sure the performance doesn't degrade too much. In Bing, for example, they're on the top 1,000 queries, and see that when somebody types Facebook, we do return Facebook as the number 1 result. That helps. Things like that run. Then the system, this is sort of an interesting step that we use to improve the reliability of our results. And again, something you don't think about. Normally people say throw a random seed, split your population into control and treatment. Well, it turns out that we found too many cases where we were just unlucky. Meaning, a few users that were like really good fell into the control and treatment. And when we look back at the experiment, it looked like there was a skew even in the beginning, even before the experiment started, there was already a skew. So we have this idea called Seed Finder where we try hundreds of splits against historical data. And we say, had we split last week this way, would we have passed all the metrics as sort of, nothing stat sig? And so we do this thing, we evaluate them, and then we pick a seed that historically tended to show very good stability, and that's how the experiment starts. We start the experiment at a low percentage. We might go with 1%. We'll also go and pick a single data center as an example. So we had these, again, everything here is built on scars. So we had these bugs in the past where you would launch it at 1%, and it had a memory leak, and it would take several hours for the memory leak to bring down the whole data center. But if we shipped it to multiple data center, we brought all the Bing down. This is the way for us to test in a relatively isolated environment, single data center. You run for a few hours, the data center survives your feature, then we deploy to other data centers, right? These are things that take a while to develop. We compute cheap metrics in about 15 minutes. So as the experiment starts, there's very few metrics, think about 10, that we start to compute in near real time. And the whole idea is just to detect egregious errors. Right? If you think about medicine, are the patients dying? No, they're not. It looks okay, then we ramp it up. We'll run for a few hours, we'll compute more metrics, and then the experiment will ramp up to the large percentage that you want to run it. We typically run experiments about 10, 20% on Bing. It's a very large site. Most of our other sites will run 50-50 basically to get the most statistical power that you can. And again, people sometimes comment, what do you mean you exposed to half the users? Yeah, I'm pretty sure it doesn't kill them. We ran this egregious test, and then we deploy it out there and see that everything is good. And we get the most power, the ability to be agile comes from the fact that you launch it, you ship it to a lot of features. And then after a day, we go and compute a real scorecard. Thousands of metrics. I'm not kidding you. There's when you run an experiment on Bing, there's about 10,000 metrics they can pick from. There's templates, and they'll get 2,000, 3,000 metrics. And the reason for this large number is that we always keep metrics out there for the surprise factor. You made a change here, you didn't realize you're hurting this other component. And so every team can, come up with their own set of metrics, and then we just run the whole gamut. It does cost us in computation power, but definitely worth it. Remember, the cost of electronic data collection is pretty small. It's not like in drug design where you have to interview people or do things like that. Okay, I want to go into the 5 lessons, right? 5 things that I think are worth sharing with you. The first one is get agreement on your OEC, your overall evaluation criterion. What are you optimizing for? You will be shocked how hard it is sometimes for groups to articulate cleanly what they're optimizing for. Oh, we do this, and this team wants us to do that, and we do this. Very, very hard thing to do. Now, the harder thing about this is that I'm asking you to tell me what metrics I should look at in the short term over the next week or 2. That's usually how experiments run. But it has to be predictive of some long-term strategic goal, right? Coming up with short-term metrics that predict your long-term success is a very, very hard thing to do. Encourage you to think about lifetime value, not immediate revenue. There's an example, I won't go into details, but at Amazon when I was there, we initially were sending emails, and all we were measuring was revenue generated from the email. Right, think about it, it's a reasonable thing. How much revenue did we generate from the emails? But it's a terrible OEC because it can only go up if you spam users more and more. Right, it's sort of this non-monotonic thing. You send more emails, you get more revenue. You send more emails, you get more revenue. Once we start to think about, wait, what's the negating factor? It's these unsubscribes. When somebody unsubscribes, we have to subtract our long-term ability to email that person. Right, so it's the lifetime value of all the future emails for that person. Once we added this term to our OEC, half the emails that Amazon were sending were negative. Right? So think about coming up with this metric like that. Look for success indicators. Are the users having a good day? Are they suffering? Avoid a lot of the vanity metrics that we see out there. Great book I recommend, How to Measure Anything, right? Some things are hard to measure. I've had people tell me, look, what I do can't be quantified. Well, if I can't quantify, if I fired you, would I notice? So it's really hard, but it really is important to try and quantify. And sometimes you have to sort of go to what I call, second tier, like surveys. I don't like surveys a lot. They annoy the users. They're unreliable, high variance, small numbers. But sometimes we have to at least use them in the beginning to understand what are metrics that are correlated so we can, over time, derive the OEC. There's a bunch of fun talks I'm giving, you're getting copies of these talks. So the very famous pirate metrics about acquisition, activation, retention, revenue, referral, it sounds like R, hence pirate metrics. And then don't be afraid of using multiple things. Say we're optimizing for this and this and this. The hard part is weighing them, deciding how much weight to put on X or Y or Z, so you end up with ideally a single metric that tells you ship or not. Really, really hard. Took us multiple years at Bing to come up with a single metric that determines if somebody can ship or not. For a long time, we were just, okay, these are borderline, let's go up for discussion, and that's okay in the first few years. But once you get to a single metric, think about this, you can start running automated algorithm, automated experimentation, parameter sweeps, and do things, and you know when to ship, so it's really nice. Okay, a cool example, again, I'll share with you is Microsoft support. People, folks came to us from the Microsoft support side, said, Ronny, we read your paper, we know what an OEC is, and I said, what are you optimizing for your support site? And they said, time on site. I said, wait a minute, time on site? Like, is more time better or more time is worse because you want to finish quickly? Then you realize that half the room thought that more time is better and the other half thought that they agreed on the metric, they didn't agree on the direction. So these are hard things. Bing optimizes for query share. Over the long term, we want to take bigger share of the market, right? Adil in his intro showed you this graph where we grew from 8% when Bing launched in 2009 to now over 23%, plus there's another 10% from Yahoo, which is really serving Bing results. So it's our long-term goal, but what do we optimize for in the short term? It turns out that you can actually get more query share if you degrade algorithmic results. If you show shitty results, people will issue more queries. It's like, this isn't good, so they refine the query. This doesn't get me, so they refine the query and make it longer. And then they make more queries in the short term, but if you want to fire the relevance team, you'll make more money for about the first few weeks, and then you'll die. So we can show more ads. It's very easy. We know that it makes us more money in the short term, but of course we also know that it increases abandonment. It's one of the clear experiments that we've run to show that when we show more ads, sessions per user, one of our North Star metric, declines. There's fewer sessions later on in the experiment. Right, so we can tell after a week that some users have already abandoned us when we start to show more ads. So this becomes a constraint optimization problem. Instead of just telling them to make more money, we tell them you have a certain number of pixels, vertical pixel on the page. It's your job to use this space to show ads, and we only care about the average. So for some queries, show 0 ads. For some queries, show 4 ads. But on average, we allow you this number of pixels. That's an optimization problem. Now it becomes a very challenging problem to work on, and it's a great one. Some bad examples. This is actually from talks that I've seen that I'm like, oh my God. So here's a talk where somebody showed that if they look at these 3 things that they're showing on the bottom, and they move this one to the left, right? So it starts in the middle and they move it to the left. The call to action is it raises clicks by 109%. Well, guess what? Next week, the thing on the right is also going to move left. That will also increase, and they'll keep rotating, and every experiment will be successful, right? People read from left to right. Things on the left get more clicks. What are you optimizing here for? Don't optimize locally. The fact that you move this guy to the left means you cannibalize the thing that was on the left, right? So what you really need to do is think about an OEC where you look at the overall page as a unit and optimize on something like, this is an idea, the clicks times the value assigned to them per user. Here's another one. Somebody comes along and says, hey, 2% of our queries come up with no results. What's our gut? Wow, let's have a project. Let's make sure that we take this number down to 0. We should always show results. And when you do that, if you don't think about it, you are starting to generate shitty results. Here's the example. I type brochure paper on Amazon Prime now, and it shows me this piece of crap paper. Right, so no results doesn't really mean a good thing if you start showing results. You have to think about the quality of the results that you have. Sometimes it is a good idea to show no results and get the user to think, maybe I don't have this product. Last example in this case is an OEC that we used in a real experiment. So this is Office Online. They tested a new design for their homepage. The area in reds are things that are called revenue generating links. You know, here's two of them. Here's this one and this one. The question was, which design is better? And there was a problem with this. Okay, what they used as OEC is clicks on these red areas. And when we got the result, we said, wait a minute, something is wrong. I'll leave it on the screen for like 30 seconds for you to think about what is wrong with this OEC that measure clicks on the red areas. Anybody want to call out? What was that? No, it's clicks. Yeah, so that's the reason. But why would clicks not be a good predictor? They told us that clicks have a conversion rate of, X%. Right, so they're using an approximation, but the approximation, they said, click converts to a purchase with some percentage. The problem is there's something here that causes the clicks to conversion rate to be very different. Okay, and the reason we found that out is like there was a 64% change. Now, whenever somebody tells you there's a 64% change, stop, something is wrong. This never happens. Okay? The problem was that the price was shown only in one of the two. So let me go back. See here? This has the price. This one doesn't. As soon as you make this difference, there is a massive difference in the conversion rate. People on the left have to click to see the price. People on the right don't. So sometimes you find things in hindsight, and again, somebody comes to you with 64%, call Twyman's law, which is I'll share with you in a minute. And again, I think that the gentleman here pointed to the right thing. The fewer assumptions you can make, the better. Measure the real price. Now the problem is people say, oh, you mean I have to hook into the billing system, it takes a while, it's gonna be slowing, let's do this. And sometimes it's okay to make that trade-off, but in this case, bad idea. Okay, lesson number 2, most ideas fail. We all build features because we think they're useful. Most experiments show that features fail to move the metrics they were designed to improve. Overall at Microsoft, we have about a third, so rough approximation. So a third of our ideas are actually positive, stat sig. A third are flat, they do nothing. Generally, if something is flat, we recommend to the teams, no, ship. You're complicating the code, you're introducing more bloat, don't do that. And actually that surprising thing is that a third are negative. Now in areas that have been optimized for a while, like Bing, the percentage of the bottom two goes up to about 80, sometimes 90%. Right, so this is what Adil showed in the early introduction. We have a metric, sessions per user, which is our holy grail. If you can move sessions per user positively, that means users are visiting you more. 1 in 5,000 experiments is able to move this metric statistically significantly correctly, meaning replication. With those odds, if you get a p-value of 0.05, don't trust the results. Right, because 5% of the time, you should get this by chance, and this tells you this is 0.02% of the time where this can move. Right? Replicate. You have to run twice in order to convince yourself this is a real movement. We had a project for 2 years where we integrated with Facebook and Twitter. We built a third pane. We had 100 engineers work on it for over a year. 0 value. We could never get this to work. We shut it down after spending, tens of millions of dollars on it. So yeah, our joke is that we tell our clients, the new baby is ugly. Okay. So first, the key lesson, avoid the temptation to build optimal features. Try to go through it. We used to do that. Office used to ship every 3 years. Now it ships monthly. Very big change. Culturally hard to do. Experiment often to having a great idea, have lots of them. I love this quote. You have to kiss a lot of frogs to find the prince. Find more frogs, kiss them faster and faster. This is what the platform allows you to do, right? It's cheap to experiment. That excuse of, I don't have time to experiment, goes away when the marginal cost of running the experiment goes down to 0. This is what the platform allows you to do. And then great talk by Sir Ken Robinson about, prepare to be wrong. Okay, small changes can have a big impact, right? This is sort of what all these keynotes are about. Somebody comes in, my opening example, we did this simple change, we generate $100 million. It's, we had a text box. If you look on your left side of Windows here at the left, there's a little text box that allows you to search. After a year and a half after we shipped Windows 10, we decided to experiment with that. And luckily, this was a server-side text string, so we managed to run the experiment. We tested 4 strings. One of them was worth $5 million more annually. Nice morale event for a text change. We added site links to ads, $50 million. Look at this thing. Can you even tell the difference in shades? $10 million by moving from the left to the right. Right? Not a bad way to change some RGB colors and get $10 million. And then we had 100 millisecond improvement to Bing. Somebody found a more efficient way to write some JavaScript that made the page 100 milliseconds faster. A lot of money. We have this saying, every 4 milliseconds that you improve on the Bing server funds you for a year. Right? That sort of emphasizes the importance of performance. And then we had this, another article. We opened a link in a new tab, increased clicks per user by 5%. At Amazon, when I was there, we added this credit card offer. It was worth tens of millions of dollars annually. Another one was we found we have a lot of, malware. We overrode the DOM routines. That saved us millions of dollars annually. So these happen a lot. They do impact. It can happen. But most of our improvements, this is lesson 4, are inch by inch. As Al Pacino said, it's tough. Most people have very small improvements to our key metrics. We have a team, the relevance team, a few hundred people at Bing. Their goal is to move a single metric 2% every year. That's it. We sum up their experiments and we say, did you meet the goal of 2% every year? And they do this very nicely, but it's all small movements. The Bing Ads team, they improve revenue by 15 to 25% every year. But the number of years where they had that first example that I showed you, if I remember correctly, from 2009 to today, there were 2 examples that were worth $100 million. Most of their stuff is like this. Huge number of small shifts. They test hundreds of ideas. Every month they combine them and they measure it, and it's a small delta. And you can see a few things here that are interesting, like these are the holiday spikes where there's a lot more intent to buy, so we allow them more space. But this is I don't have the y-axis labeled here for obvious reasons, but this is about 50% improvement over a couple of years. So lots of improvements. Sometimes you launch something and seasonality tells you you're going down, but you can detect that in a controlled experiment you've actually improved something. And the last one is validate the experimentation system. This is where I think companies like Optimizely got it wrong, right? They initially came out with a version that was not statistically justified, and then you see these articles about, I ran this AA test and it became stat sig a lot. Or there's a famous one blog where somebody said, I almost got fired because of Optimizely. You gotta work on the details, and these are hard. Getting numbers is easy. Getting numbers you can trust is really hard. Look at these 3 books. They're great books to read. They're fun. They all get the stats wrong. Right? So you look at my reviews. I think I'm #1 review on all 3 of these. You can see why. They're all getting the stats wrong. Other things to do is check for bots. You will be shocked how many bots there are. Now, Bing is a good target for bots. But look at this number. 50% of our US traffic is bot generated, and in China and Russia, it's 90%. Right? If you don't remove this, everything is noisy. Run AA tests. An AA test is when you split the traffic into 2, but instead of an A and B, both sides are A. What do you expect? No change 95% of the time, right? If your system doesn't tell you no change 95% of the time, you have an error. And so here's an example. You run an AA test, you run a lot of them. By the way, you don't have to actually run them, you can just simulate them. And then you can see something is wrong with your statistics. This is an incorrect computation of the standard deviation because the p-value is very skewed, heavily weighted around 0. So you figure out, boy, I can't use the stats 101 formula. I have to do something else called the delta method. Happens to us a lot. This is after you correct for it. Looks much more uniform. And then another one that's really, really important, something called a sample ratio mismatch test. If you run an experiment and you plan them to be equal percentages, you should check that they're about equal, right? So here's a real example. I wanted to run an equal percentage. I got 821,000 users here and 815,000 users here, and the ratio is 50.2. Now the ratio should be 50-50. I got 50.2. Is that a problem? Yes, with big numbers, this should not happen, right? If you do the math, the p-value is 1e minus 6. That should happen 1 in 500,000 experiments, right? If you get the lottery ticket on your first experiment run, you should say, like, what the heck is wrong with this, right? I shouldn't have gotten an event that happens 1 in 500,000. So do the test. There's a link. All these things, by the way, are on a website that I'll show you at the end. Final thing is Twyman's law. In one of the books, it was called the important single law in the whole of data analysis. What does the law tell you? How many people heard of Twyman's law? 1, 2. Okay, listen to this. Any figure that looks interesting or different is usually wrong. Please, when you get a result that looks too good to be true, don't celebrate. Say, Twyman's law, spend 9 out of 10 times, Twyman is right. The 1 in 10 or 100 is the first big example that I showed you. Some examples, we've seen data where, if the site, people don't think they should give their birth date, you will see tons of people working on, been born on 11/11/11 or 1/1/1. The auto repeat works really well in those cases. If you have an optional drop-down, do not force to the first alphabetical order. You will have lots of jobs equal astronaut that starts with an A, because if it's default, people don't change it. Traffic doubled on some sites. Why? Daylight saving. So all these things, if you see the OEC move too much, call Twyman's law. Okay, let me summarize here. Love this quote. The less the data, the stronger the opinions. Think about your OEC. Make sure you understand what to optimize. Realize that it's hard to assess the values of your ideas. And so listen to your customers. Get the data with controlled experiments. And then prepare to be humbled. This is one of the things that I love about this domain is everybody makes their guesses. We sometimes do bets with, who's going to get this experiment right? What's the percentage? And most of the time we're wrong. The statistics are hard to do. The stats 101 works sometimes. The assumptions about independence don't hold when you have ratio metrics or other things. Learn more, run these AA tests. And then run experiments often, because the more you run them, the more opportunity there is to improve the product. You get to pick what to ship. And so if you make it easy to ship, things improve. And then at the end, I got this website, exp-platform.com. We have a lot of papers there, lots of talks, tutorials. If you want to get a lot more information, there's an advanced section with a whole bunch of advanced topics for you to answer. Thank you very much.